Hello folks, this is a 2022 February-March session, paper 1-2, and the question number is 9. This question is concerned with the chapter kinematics. We can see forces as well because it deals with some opposing forces and it deals with the graph of V and T. It says an object falls freely from rest in a vacuum. Yes, in vacuum, no air resistance. The graph shows the variation with time t of the velocity v of the object. So something is falling like this, not a throwing, it just falls. So the graph is for v and t. Which graph using the same scales, that means same scales here, same proportions, represents the object falling in air. So now we have to find the variation of velocity for that object which falls in air. So in air means what happens is, let us just study the general pattern. If it falls in air, initially at the very beginning, initially we have a equal to g, and at that time v equal to 0. Initially v equal to 0 and a equal to g. Then later what happens is a decreases and v does increase. Finally what happens is, we have a becomes 0 and v becomes constant and maximum. With the condition is called as terminal velocity. At that time the velocity is called as terminal velocity. So if I go to the pattern, we have the v increase, v0, v increase, and ultimately v becomes constant. V has to become constant. So if so, then we have some of the graph already disqualified. So this graph disqualifies because it does not say anything like a v constant. This disqualifies because it says a v will vary even rapidly and so on. These dotted lines are copies of these lines. These dotted lines are copies of this line, and they are parallel to this. They are parallel to this thing. I have drawn it to act as a reference. Now, among these two, here also v is going towards being constant, and here also v might become constant on the long run. But what I'm saying here is, let us go through initial conditions. Initially, we have a equal to g. A equal to g means we have a equal to slope of VT graph. So initially, what happens here is, here also a equal to g. It has got a certain slope here. The value of the initial slope of these two should be equal to this. Slope. The initial slope of these two should be equal to this. So if I go through this b, it is not equal because this slope is higher. This slope is higher than this. So here it means that this is incorrect because initially the value of a should be equal to z. That means the slope of vt should be equal to this, but not equal to. So that's why it's unequal, and here it is equal. The slope is equal because we have drawn this as a copy of this. So initially slope is equal, slope decreases, and here it might give us constant velocity or 0a. So this is choice C should be correct choice.